Okay, welcome. So let us start with a sequence. More than on any set X, we can define a sequence in a set X. What is X is a non-empty set. Set means a collection of well-defined objects. Then we define a function from the natural number, n set of natural number, that is 1 is natural number, 2, n is natural number means n plus 1 is natural number. We want to define a function f from the set n to the capital X. N to capital X, f a function from the set of natural number to X. So function means what? For each element. So 1 belongs to natural number. With this we associate a unique element f1 belongs to capital X. With 2 f of associate a unique element that we call f of 2. This belongs to X. With n belongs to n, we associate f of n. This we denote by x suffix n belongs to capital X. Then we say that f of n is image of the natural number n. F of n, which is written as xn n1 to infinity, is a sequence in capital X. Our set capital X. That means 1 x1, 2 associated with x2, n associated with xn, each xn belongs to capital X. So we have a sequence in capital X. But our interest is, first let us start with x equal to r, a set of all real numbers. We have discussed already to some extent what you mean by real numbers. We will assume that those who are listening online, I will recall when we need what is called LUB axiom, that time again we will recall what is LUB axiom. Right now we want a sequence in arming. It is a function from n to r. That means xn n1 to infinity, a sequence in r. That is n goes to fn equal to xn belongs to r. Then we see what is called increasing sequence. Increasing sequence, or another name is, what is that? Non-decreasing. Correct? Increasing a sequence, because in R, what is given? xn n1 to infinity, a sequence in R. Then this sequence is said to be a monotonically increasing sequence. xn is said to be a, see, it is understood that we will not write every time n1 to infinity. It is understood that xn means n1 to infinity. Infinity is not a natural number or not a real number. But what is 1 is a natural number, n is a natural number, means n plus 1 is a natural number. We have seen that no upper bound for set of natural numbers. So xn is, again I write in short, sequence in R. That we have written sequence in R. Xn is said to be a monotonically increasing sequence. Definition means if for this I am writing for if and only increases. That means what? First term x1 less than or equal to x2. Very good. Less than or equal to nth term is less than or equal to xn plus 1 for all n. For every natural number n, xn less than or equal to xn plus 1. Then we say that the given sequence is monotonically increasing. We'll just say that increasing. We will not use every time monotonically. It is an increasing sequence. Note that we don't say that increasing means even this sequence 1, 1, 1, 1. This is a monotonically increasing sequence. We don't say that it is strictly increasing. When we say xn is strictly increasing, that is strictly xn is strictly increasing if and only if, you can just write if and only if, that case xn is strictly less than xn plus 1. Then like this sequence 1, 1, 1 is not, it is increasing but not strictly increasing. In fact, our interest is, will be mainly interested in increasing or say monotonically increasing or decreasing means the reverse. When we not write, when we say xn is a decreasing sequence, decreasing or another name is monotonically decreasing. When so the natural way decreases like 1 by 2, 1 by 3 decreases. It is strictly decreases, but what we xn is a decreasing sequence if and only if x n greater than or equal to xn plus 1. Then we say this is for every natural number. For all n belongs to n, that is x1 greater than or equal to x2, that means x2 is smaller, then x3 is smaller than x2 and so on. xn is greater than or equal to xn plus 1 means the go away, keep reducing, not strictly. That's what this sequence 1, 1, 1, it is monotonically increasing as well as decreasing. But if you say that, we can write any sequence means, suppose we write 1, 2, 1 by 2, 3, 1 by 3, 1 by 4, 3, then 4, so that 1 by 4 and so on. What type of sequence? Is this sequence, I mean this is our sequence xn. First term is 1. 1 is associated with 1, 2 is associated with 2, 3 is associated with half x1, x2, x3, x4 and so on. Is this a monotonically increasing sequence? No. Decreasing? No. It is neither increasing nor decreasing. So that we can easily give example. A sequence need not be increasing or decreasing. But what we are going to see is, you give any sequence in R, no restriction. Whatever sequence you give, see here, this is not increasing or decreasing. What you observe from here, what can you say about 1, 2, 1, 2, but then 3, after that 4, then here 5 will come, then 1 by 5 and so on. So naturally n comes, then 1 by n. Then if we start with first term is, that's what we call it, xn1 is 1, xn2 is 2, xn3, okay, general term, we write the formula. Then this is what type of, is it a subsequence? Yes. It is a subsequence. What type of subsequence? It is monotonically increasing. It has a subsequence which is monotonically increasing. Original sequence is not an increasing or decreasing sequence, but it has a subsequence which is monotonically increasing. Also, the same sequence, now instead of take 1, now first term is same thing, xn1 is, this is another sequence. If you want, you can write yn1. So we'll just write, now that is over. xn2 is second term half, xn3 1 by 3 and so on. Now this is a subsequence. What type of subsequence? Now it is monotonically decreasing. So the same sequence can have even constant sequence. Of course, even if you write 2, 2, 2, that's what we have seen that it is both increasing as well as decreasing. Anyway, these are all simple examples. We will not spend more time. Any doubt? Those who are listening online also, they are welcome to ask questions. They can ask me. So that's the main thing, is to motivate you to understand the concept. As I told you, my aim is not to train you for writing competitive exam. Make you to understand the concept, then do some problem, then you will be able to spend some time and solve problems. So then we have seen that what is LUB. Those who are attending first time, they may not, you may remember or you may not know, least upper bound, LUB, least upper bound axiom. Quickly recall, A non-empty subset of R. A non-empty subset of R. Alpha belongs to R, need not be in A. Alpha upper bound for A, when we say if and only if x less than or equal to alpha. That's what alpha a real number means. Go to the real line. Alpha is here. We are not telling that if conditional x less than or equal to not for all x in R, we are not telling for all x in A. That means x is in A, mean x less than or equal to alpha. That means including, it may be X is left side, it may be equal to also. Alpha may be in A or it may not be in A, no restriction. But X is in A mean X should be less than or equal to alpha. Then we say alpha is an upper bound. Every set need not have an upper bound. That's why we need LUB axiom. If a set